Hi everyone, thanks for coming along. In this session we're going to be talking about how to go into production on Heroku with confidence, covering scaling, load testing, and then once you're in production, looking at the problem management side of things.
Hi everyone, thanks for joining us. My name's Abhinav, this is Max. We're from Trineo, which is a long-standing Heroku partner. Max is one of our senior engineers who's been with us for a number of years, and in the last couple of years particularly, he's had a lot to do with our extremely complex and non-trivial deployments on Heroku. He's based in Oslo in Norway, but don't let that fool you, he's a Kiwi. And my name's Abhinav, I'm the CTO and co-founder of Trineo. I'm the principal architect and consultant on many of our projects, and I'm based in Boulder in Colorado. Thanks for joining us. And this is a forward-looking statement slide that you've seen many times, and we're going to skip over it to the next slide.
Cool. So in this session, we're going to be starting off looking at scaling. So looking at the key componentry of the Heroku platform, namely Dinos and databases, and just ensuring that you've got that configuration appropriate for your application. And then once we've looked at that, we'll look at how that feeds into load testing. So using load testing to ensure that your application configuration is correct and it is going to handle the expected load that you need to. And then we'll finish up by looking at problem management, just ensuring you've got a plan for success in case you do have problems in production. You can identify those and make sure that you can follow up with that and fix what's going on there. And we'll have a couple of demos to illustrate these concepts throughout.
All right, let's talk a bit about scaling. To understand how to scale your application on Heroku, you need to understand the componentry that Heroku has to offer you. And we'll cover two parts of the componentry being Dinos and databases. So let's talk a bit about Dinos. A Dino is a discrete amount of compute resource that you're offered by the Heroku platform, and it's essentially defined by CPU and memory, and a very small amount of file system upon which your application code will run. If you're interested in knowing why it's just a tiny amount of file system, learn about the 12-factor app. There is a presentation about the 12-factor app, and also look it up online. It's a really good discourse on how to construct and deploy horizontally scalable applications on a cloud platform. So Heroku offers a number of different types of Dinos, and you can see up here behind me a number of types. So the first two, free and hobby, are really useful for spiking on a problem or putting up a proof of concept or something of that kind. And then beyond that point, when you start pushing into perhaps a UAT or a production environment, that's where we recommend that you use a standard type of Dino. Standard Dinos come in two types, 1x and 2x, and that implies that one is double the size of the other. And the standard Dinos are really useful in circumstances where your application is typically handling an HTTP response request lifecycle and is just putting responses back via queries that are made to an API or a front-end app. And ideally, you can add more and more standard Dinos to scale up. But if you have an asynchronous workload where you've got to do some heavy lifting, which is outside of the typical HTTP lifecycle, the performance Dinos or the standard 2x Dinos are really useful because they offer you larger compute resource. In the case of the performance Dinos, what you'll find is that you get a dedicated host underneath, so there's no resource contention under the hood. You're guaranteed to receive the discrete resources that you're told that you will have. So it's a really good idea to understand the way your application behaves in concert with what you're offered in terms of the Dinos that Heroku provides.
And then the other side of things is the databases. And when you're thinking about databases, you want to be thinking about three things. So it's the amount of data you need to store, so your data volume, the number of connections to your database. Typically, all databases have a connection limit, and then the performance of the database. And typically, that's defined by the caching, or the amount of memory that's available to that database. So when you're thinking about the connections, you need to be thinking about how many connections are you using per Dino. Typically, this may be different for your worker and your web Dinos. So you need to determine that information. And once you have that, you can identify which database is appropriate. And so we've got two scenarios here. With the 1x Dino, the standard 1x, we've got 10 of those with 8 connections each. And so that's a total of 80 connections per your application. And if we change to a 2x Dino, we might be running the same 10 Dinos, but each of those could be using 16 connections, giving us a total of 160. And that may be over the amount that your database provides. So you just need to ensure that those things are in sync. And then from the data volume perspective, this is really dependent on your application. So you just need to ensure that you choose a database which has sufficient volume and with some breathing room to grow if you need to, because you don't want to be running out in production and having to upgrade your plan in the middle of customer usage. So you can give yourself some room so you can schedule that in and make that change. So in the case of Redis, as a typical database we use on Heroku, so the sizes range from 50 megabytes to 100 gigabyte, and the connections from 40 to 10,000. So it's really just about choosing what's appropriate for your application, and we'll look at load testing a bit later to identify, or help identify what we actually need. And then in the case of Postgres, sizes range from 64 gigabytes to 1 terabyte, and connections from 120 to 500. So in that scenario earlier where we had 10 dynos with 16 connections, we had a total of 160. That would be over the 120 limit on the basic database, and so you'd be missing out on being able to connect to your database and retrieve that data. And something else to think about here is that you don't want to be using the hobby databases. You always want to stick to the standard or performance databases, just because they don't behave the same and they don't give you the same performance characteristics. And then another consideration with the Postgres is that 500 is actually quite a low number in terms of connections. So there's a few tricks that you can use to get a bit more out of your database. Namely, you can use follower databases so you can read from those followers, or you can use a build pack called PG Bouncer, and then you can consolidate all the connections for a single dyno down to one connection, giving you a lot more breathing room in terms of connections. So you can see a table here just kind of highlighting the differences between some of these plans. You've got the hobby, the standard, the premium, and the enterprise. So it's really just choose what's appropriate. And again, you don't want to be using hobby in production.
So the question is, how many dynos do you need for your application? When you're talking about scalability, in the panacea that is the cloud platform as a service, the notion of just adding more dynos isn't one that may solve the bottlenecks that you may find. You actually end up pushing resource contention deeper into your stack. And as Max was showing you earlier, if you increase the number of dynos, you increase the number of connections needed by your application as supported by your database, and you just push the performance problem deeper. So it's really a great idea to do some load testing. And in terms of load testing, what you're trying to do is to create different conditions and different circumstances that simulate load upon your application so you can see where the bottlenecks exist as load ramps up. So let's examine that a little further together.
So load testing is useful in a number of different situations. First off, you're going into production. You want to ensure that your configuration and your application can handle the amount of load you're expecting. So just before you go into production, do a number of scenarios, load testing, different Heroku configurations, different databases, and perhaps tweaking your application code when you get some feedback from those load testing. But it's also useful to highlight when you're making changes, have you had any performance regressions? Has the changes you've made introduced a problem? So you can have automated setups to do load tests across your application. And it's also good to identify what your ceiling is. So you've identified, okay, it handles the appropriate level of load, but what happens if we go above that? So you don't want to have a ceiling that's just above what you need to handle. You want to have a bit of breathing room and ensure that you can make changes as needed rather than scrambling to make those changes.
So what should you load test? Well, most of us, when we're building an application, are busy developing features because there's a deadline coming up, and there's usually very little time to do things like load testing. But it's a really good idea to test early and often. So prior to going to production, it's a really good idea that you can choose maybe the top 5 user transactions that take place. So you should simulate the usage of your application as the end user, and then record everything that takes place, whether it's a front-end application that's driving API requests to an API that you've constructed or third-party integrations. You should record that behavior and then replay it at scale so that you can continuously replay this. As Max was saying, you can continue to do so as your application grows, so you can check for regressions and you can have a baseline. So record and replay transactions. So let's dive into a demo and show you a little bit about Loader.io.
Cool. So we've got a demo application here. Just bring this down. Hope you can see that.
Shrink the size a wee bit.
Make that a little smaller.
Yep.
Cool. So this is just a simple application that has a number of contacts. Each of these contacts has a language that they're interested in learning, and then you can upload a photo for each of those contacts. And so what I've done here is I've opened the Chrome Developer Tools and just looking at the Network tab to see what requests are being made. So if this was a more complicated application, for example, had some sort of order process in it, we'd be able to navigate through that process and identify what network requests are being made as part of that. And then what you can do is download that as a HAR file, which is just a JSON file, and you can analyze and parse out the information that you need. But in this case, we can just have a look here at this timeline, and we can see that this contacts request is the most intensive in terms of performance. So it's taking around 3 seconds to get that data. And so what we can do there is just go across and create a new load test and see how that endpoint is behaving.
Make much smaller, Max.
So make that a little smaller.
That's good.
Cool. So I'll just copy this one that I prepared earlier and then kick that off. And that'll kick off the load test. So what we're using here is an add-on called Loader.io. It allows you to run load tests really easily from integrated with Heroku. And you can just see how your application is behaving. It also has an API, so you can include this in your process, and you can kind of script the endpoints that you're interested in testing. And so we can see here that load test is running. So while that's finishing off, I'll just go across to something I did a bit earlier, and we'll go across to the trends view, which is the most interesting side of things, and we can see that this endpoint is not behaving particularly well, and we've even got some errors over here where the server wasn't able to respond because we were making too many requests. And we can see that the response time is about 4 seconds, which isn't particularly good. So we'll go across to our load test, which just finished. And that's actually not behaving too badly in this case. So when I said you should never use the hobby databases or the hobby plans in production, that's what we're using because this is a presentation. So there's a little bit of variability in that behavior. But even 1 second is not particularly good. So let's dive in and have a look at what's going on there. So we can go across to New Relic, which is another add-on which allows you to have a look into your application behavior and see what's going on there. We'll make that a little smaller as well.
A bit more.
So we'll go across to the transactions view and hopefully refresh that, see if it's got the latest data. So it doesn't seem to, maybe if we can narrow this down a bit.
Go to 60 minutes.
Ending at, let's try and refresh again to see if that's going to pull up. So this is going to take a little time for the data to come through perhaps, but if we had seen, what we would have seen is all the transactions for the application, and the most intensive one is the contacts request, and that will use about 90 or 99% of the time. And then we can drill into that a bit further and see, okay, is it the database that's using all the time, or is it the actual application code? And in this case, we would have noticed that there's very little time being spent in the data side of things. It's all being spent in our application. And if we go across to our application code, hopefully that's, yep, you can see that. And what we would have realized is that this is the code related to that. And this particular piece of code, just to give you some context, is returning all the contacts from the database. And in the database at the moment, we've got about 10,000 contacts. So it's returning all 10,000. That has to be processed by the application code and then sent on to the browser. So what we'll do to improve the performance of that is just make that a little bit less. So we'll just say contacts. So just some very simple caveman pagination. So in a real application, you'll be wanting to add actual pagination so that you can actually access all that data. So we'll go and push this up to Heroku. And then we'll go and run another load test and see how that behavior has changed. And as part of this process, you could be running your load tests automatically, and then you can determine, has this change I've made improved the performance, or has it got worse? And so you can look at things like Heroku Flow, or just using your CI, continuous integration tools to do that for you. So that's deployed. Let's go back across to our contacts endpoint, and we'll just kick that test off again. So there we go. And then now we're getting an average about, oh, it's going down again. Yeah, so the average has improved quite a lot. We compare that with the previous test. It was right about 900, and now we're getting it down to 400. So it's about halved our response time there. And then if we go across to here, and we had a 3-second wait here. So let's see what happens when we just refresh that page. So we've got 600 milliseconds. So that's quite a significant improvement.
Thanks, Max. So we've covered load testing, and of course, we've just shown you about troubleshooting endpoints using New Relic, even if New Relic doesn't work, which is great. So we should move forward into incident management. So you've put your application into production. You really ideally need to do so with a plan to handle incidents as they take place. So the thing that you need to consider is to be proactive in how you put together a notification strategy. So when something goes wrong, you ideally need to be notified about it, so you need to be informed, and then subsequently, you need to be prepared with an approach to managing the incidents that take place. So as we just showed you, you can use New Relic and the instrumentation it offers you to basically look into exactly what's going on and make some choices as to how to deal with the performance bottlenecks that you may be seeing.
Cool. So in this slide here, we've got a scenario that we quite often see. So you've got a front-end application and a back-end application. The back-end application provides a set of APIs which are consumed by the front-end application, and each of these applications have a number of Heroku add-ons. So in this case, we've got Papertrail and New Relic being used by both of these. So this is for Papertrail is used for logs. So you've got your Heroku platform errors going in there, or your notifications, and your application logs going in there as well. And you've got a historical record for that information. And then we've got New Relic, so we've got we can track the performance and any exceptions that occur in the application. And then in the case of the front-end application, we also have Sentry, which allows us to monitor any errors that happen in the JavaScript side of things. And then all of these have a series of alerts set up so that when something goes wrong, we get a notification going into Slack. So at Trineo, we use Slack quite extensively, and we have a series of channels set up, and we just have the notifications going into appropriate channels based on certain criteria.
So there's two aspects of logging that you need to be aware of. When you're deploying an app onto the Heroku platform itself spins up messages and emits them into your log stream, indicating that it has noticed that something has gone wrong. A classic example of that is when a response takes more than 30 seconds to generate. If your application hasn't responded in 30 seconds, an H12 error is thrown by the routing fabric, and that's injected into your logs. And that needs to be trapped, captured, and then you should be notified about that, and you should do something about it. So there are Heroku platform errors of that kind, and then subsequently, of course, your own application behavior. Now that is a little trickier. All the Heroku error codes are described, and you can trap them and catch them and do something interesting with them. But your application is something that you may know about to an extent, and then when you're in production, you should be watching for problems that take place beyond the typical 500s, 403s indicating authorization issues, and be able to address the needs that you have as you learn more about your application. So we're going to show you a little bit about that in a moment as well. The other aspect of logging that we typically use is using request IDs. So we inject request IDs into all of our logs such that the responses that we provide to our consumers, whether it's via an API or it's within an app that we've built that's using one of our own APIs, we're able to use a request ID and identify an end-to-end transaction that's taken place. So you can search by a request ID, and we'll show you that shortly, such that you can isolate in a lot of noise, typically within logs, an area of concern and be able to focus on a problem with a single request ID. And you can use an IP address alongside with that to even narrow it down further if you wish to. Another concept that we use quite heavily is where if you have multiple services or multiple applications transacting with each other, you can proxy and forward that request ID such that you can watch how that request tracks through multiple applications and then routes back again. And that's quite a handy thing when you've got handoff from one thing to another, so that you don't lose the continuity of information from a transaction end to end.
Cool. So now that you've got all these systems set up so you can monitor for problems, something that we find quite useful is to set up a series of smoke tests. So these will go through and exercise your applications in different ways. And then if something goes wrong, you can have errors coming through from your notification channels saying that something's gone wrong during that process. And you want to include this in your change process. So you've added a feature, changed the behavior of a feature. You can have your smoke tests run automatically when that gets deployed to your UAT and production environments, and you can detect any problems there. So that's a really good thing to have set up. And typically in production, you'll have a read-only view, so you might go and log in, exercise an order process almost to the end, but not actually make a purchase, because you don't want to be filling your database with bad data. But in your UAT environments, you can set this up to be a lot more extensive. You can have it mutating data, creating users, creating orders, deleting things as necessary, and just exercising your application more fully. Cool, so we'll jump into a demo now and just show you how we typically do this. So going back to our application here, as I mentioned earlier, we can upload photos. But what happens if someone decides to upload something that's not a photo? So in this case, we'll just jump over here and we'll upload this text file. So this is going to be going off to Cloudinary, and then we should get an error come across. So we've got an error in the console, and I'll just jump across to our Slack channel and see what we've got there. Cool. So we've got an error come through, unable to upload the photo. So this will open up Sentry, and this will give us some really good information about what's happened on the user's actual browser. So we can see their IP address, we know what type of browser they're using, their operating system, what URL they were on when they saw that problem. And then we can go down a bit further and we can see a stack trace, so we can really dig in and find out what part of the code is causing the problem and where we need to make some changes to handle this better. And then further down here, we can go down and see what did the user do before they saw this error. So in this case, they clicked on the image and then they tried to upload a file. There's a bit more information here. And then something I find really useful is this additional data section. And so you can add a bit more context to your errors. And in this case, what I've done is I've added the name of the file and the size of the file in the additional data. So I know that this is actually a text file, and I know that it's quite small. So if I was to try and fix this problem, I'd be able to say, okay, we need to tell the users that they're not allowed to upload text files because they're not photos. And if this had been a request to our own servers running on Heroku, we could have used that request ID and put that in here as Abhinav talked about, and then we would have had a link from our front-end errors to our back-end logs. And if that had been the case, we would have come across here to Heroku, to Papertrail, and been able to have a bit of a look around and see what's going on. So at the moment, there's quite a bit of noise, but if I just take one of these request IDs, which is logged, I can isolate that noise and just look at this one request. So in this case, this request was successful, but it still tells me a good level of information. I know what sort of request it was, how much data was returned, how long things took, and what SQL was used there to generate the response.
Great, thanks, Max. So in summary, what we've covered is the notion of understanding scalability on the Heroku platform. So most importantly, understanding two things. How does your application behave? What does it need in order to process requests? And then what does the Heroku platform offer you in terms of its componentry to be able to deploy your application onto it? We covered Dinos and databases in that sense. And then to test how your application will scale, you hit it with load tests and understand, therefore, even better how your application behaves in the various layers of the stack as you put load onto the system, and finding bottlenecks under different circumstances and different conditions, so that you're informed about when your application becomes insanely successful and then what you need to do in order to scale it appropriately. Finally, we talked about an incident management plan, which is essentially your ability to be informed about the behavior of your application before things become overly problematic or problematic at all for your users or your customers. Being notified of things that are taking place and the instrumentation that you have at your disposal using add-ons like New Relic to be able to understand how to approach a problem quickly, efficiently, make a choice, and then make a fix and push it so that you can continue to deploy with confidence as much as you like. Thanks very much. Over to you for some Q&A, if you will. No questions? Come on, someone's got to have a question. We explained that well. I'm sure we didn't explain it perfectly.
Feel free to come and talk to us afterwards if you have any questions as well.
Thanks very much.
Cool.
Appreciate it.
Thank you.
Thank you.